Hello there, folks. Cranky Old Cuber here with the next installment on the modular synth I've been building. Today, we'll walk through the VCA kit. VCA means voltage controlled amplifier, which does exactly what it says on the label. The easiest way I can think of to explain what a VCA does is to first think about what an amplifier does. The amplifier has an input, an output, and usually a volume knob. You feed a wiggly signal in one end, and the amplifier makes the signal bigger or smaller on the other end, depending on how you turn the knob. In other words, an amplifier controls the amplitude of the signal. If that signal is audio, then it changes the volume. But the signal doesn't have to be audio. To the amplifier, a signal is a signal is a signal. What about this voltage controlled thing though? Well, what if we could control the knob with a voltage instead of turning the knob with our hand? That's a voltage controlled amplifier. So the way it works is the higher the control voltage we feed into its input, the bigger we make the wiggle on the output. And as with any other signal, we can vary the control voltage over time for interesting effects. Why would we want to do this? Well, for me, there are a couple of basic cases and then a million possibilities beyond them. So the first case is we can use an envelope to control the VCA in order to shape the volume. We've talked about that before. We could use a fast attack and a medium decay to get a plucky sound, or we could use a slower attack and decay to get more of a swelling sound. In this case, we would connect our oscillator's output to the input of the VCA, and the output of the envelope generator would go into the CV input. The second use case didn't occur to me immediately because the modules I've built so far all have an attenuator for their CV inputs, but it turns out that's not a universal feature. And if you don't have one on a CV input, then you can use a VCA. Suppose you have a low frequency oscillator going, doing a 1 or 2 hertz sine wave, and you want to use that to control opening and closing a filter. Well, you can run your LFO's output to a VCA input and the VCA output to the filter's CV input, and then use the VCA's knob to dial in how much influence the LFO will have on the filter's cutoff frequency. Of course, now you have this CV input on your VCA that's just sitting there not doing anything. You could use another control voltage to modulate that knob too, and then get some really interesting rhythmic swelling and filtering going. So let's get the VCA built and see what we can do. All right, so there it is. We have our VCA built. It turns out there's two of them here. I had totally forgotten that this was a dual VCA, so that's pretty nice, and it's going to make it easier to demonstrate a couple of things in a bit. So let's get this thing installed and see what we can do with it. All right, so we got the VCA built. We got it installed here in the case. Just to review, we have in the case with us, we have our VCO that makes the noise. I've got both envelope generators in here. Got the VCF from last time. This is the new one. And of course we have the output mixer, because if you don't have an output mixer, we're not going to be able to hear anything on this video, and I'm not going to be able to hear it. So let me throw some headphones on and I'll throw a patch up real quick. All right, so very simple patch. I'm going to use this stackable cable to patch the pulse into the dual VCA's input, and then I'm going to patch the dual VCA's output into our mixer's output. Okay. Now let us plug our channel 1 into the VCA's input, and we will plug channel 2 of the oscilloscope into the VCA's output so we can see what it's doing. All right, I'm going to turn this on. So we've got square waves going into the VCA, and we have nothing coming out of the VCA up here on the blue trace. Ignore the, actually, let's turn that purple trace off. We'll use that later. Okay, so what we're gonna do is just use this as a volume knob, okay? So with it all the way counterclockwise, there's no sound coming through. Got waves going in, but we don't have anything coming out. So let's start opening it up, and you'll see the blue line split into two. And as we turn it down, then it goes back away. So that is the basic operation of an amplifier with a volume knob. Okay. So we can modulate this by hand with this knob, just by, but that's a lot of work. And these pots are, I'm going to say, not super robust. And so I wouldn't do it this way. Also, a VCA gives us this handy control voltage input. So let's take an envelope, and I'm going to use another one of these, and I'm going to take the output of the envelope and I'm going to put it into the CV for the amplifier. Okay. Now we're not going to use this envelope as an envelope, really. What we're going to do is use it as an LFO. All right, so let's loop this envelope. It should have a very fast attack and then a moderate decay. Sustain doesn't matter since we're looping it, and we don't have a gate. All right, let's make the attack a little slower. Make the decay a little slower. If you've ever used a digital audio workstation like Logic or Ableton or anything, this should start to look really familiar, because you can see the volume envelope expanding and contracting. Well, let's see if that matches up with what the actual envelope is doing. We'll put it on the purple trace. Oh, look. It's an envelope. And so this envelope up here is controlling this amplifier down here. And the only thing that's happening on this VCO is a steady stream of sawtooth pulses. So we can do other stuff like leave our decay at about 3 o'clock. Okay. Let's slow the attack. See how it goes up faster? It's a little more punchy. So I'm going to continue. I'm going to make the attack even shorter. There it is. That's as short an attack as we can get with this envelope generator. Okay. Then we can shorten up decay, and as we do this, it'll speed up our LFO. Okay. Now we can do weird stuff with this and get it like almost into, yep, there we are. Now we have audio frequencies in there that are generating extra stuff. So I'm going to change the frequency up. And then I'm going to turn the decay back down again so we can hear that. Yeah, so we got that going on. So, like, the possibilities are limitless with this thing, really. You can plug anything into this CV and make the VCA do all kinds of stuff. And, like, what I'm seeing is people like to just experiment to find new sounds they've never made before. So I'm kind of having fun doing that too. I probably spend an hour a day with this thing just messing around with it and trying to make new sounds. Okay, well, let's move on and use a gate to control this envelope instead of having it loop. This thing is a step sequencer, okay? It does a lot of stuff, but the thing I'm interested in right now is I can generate gate signals with it. All I got to do is put it in this step jump mode, and then if I want A out, which is what I want, I'm going to plug into the gate here, plug into the gate there. So if I push this button, we're going to see the purple line jump, and we're going to see things happen in the VCA. Here we go. All right. That's with a really high sustain level. Okay. You're not going to hear the decay in that because it doesn't have anywhere to decay to. We'll make the decay a little more evident by pushing it up just a little bit. And there we go. That decay is a little long, so let's try it here. I'm going to put our sustain at about noon. There we go. And then if we do that with a saw, it sounds like this. Please note, I have not tuned this VCO still, so don't worry about pitches. Just watch the envelope in the VCA. And there we go. We have an envelope opening a VCA. Here's another fun thing we can do. We can use another LFO, this here envelope generator here. I'm just going to loop it, okay? And I'm going to take its output and run it into a second VCA, okay? And I'm going to take this output and I'm going to run it into this filter, into the CV input on the one side, okay? And I'm going to turn it all the way down. The reason I'm doing this is, though, as we talked about, though I do have an attenuator here on this, which means I can turn this signal up or down, I want to show you that you could use a VCA to do that too. So we're going to take the LFO output of this, which is just slowly going up and down. Actually, I'll go ahead and use a one of these so that we can plug our scope into it. Get that on the scope going here. We can see what it's doing. Okay. Yeah, there goes that. All right, so, and we're going to control our VCF's output with it. So what we got to do is we need to take this over here and put it to the input, okay? Same oscillator. We'll go ahead and go back to pulse. I like the way pulse sounds. All right. And then we will take the output of our VCF and plug that into our top VCA, okay? Now, if I open the filter all the way up and we press a key, we should get a noise. Okay, and the filter is all the way up and we're not doing anything, okay? Let's set the filter to the middle and see what kind of sound we get there. Well, that's nice. We'll turn the resonance down for now. How's that sound? All right, we're going to close the filter all the way down now and see what happens. Yeah, that's the filter doing that. I'm just holding the key down so we get the sustained voltage. All right, let's see what we can do if we actually like control the voltage of our oscillator. Okay, I'm going to change this envelope. I'm going to make it a fairly fast attack. I'm going to make the decay about like that. I'm going to put our sustain level in the middle, and I'm going to fire off this sequence. Let's see what happens. And you can hear that filter sweeping. If we lengthen the gate, what we're doing is the gate going into here is longer, so we're getting more of that sustain before the release. So I'm going to put that back at noon. Oh yeah, I like that sound better. So now I've got a shorter decay and I've set my sustain down really low. And that's a very more plucky sound than normally we get. Now, if I turn the attack all the way down, it's very percussive sounding. You hear that? What if I turn the delay all the way down? It's almost all percussive, right? If I turn that sustain down, all we get is those clicks, okay? So if we want pitch with this short attack and decay, we have to give it a little bit of a sustain level. Otherwise, we'll never hear the pitch. We turn it all the way up. Now, if we shorten the gate down, now we're back down to just clicks again, but we can turn it back up to where it's just making a tone. All right, so hopefully that gives you an idea of what a VCA is and what it can do and why you would want one. I'm not going to go into too much more detail in this video because it's already starting to get a bit long, but I will do a video in the future about the VCA circuit and why they're kind of finicky. VCAs come in lots of different shapes and sizes. You can get modules with a single VCA with lots of features. You can also get modules with lots of VCAs. Sometimes they include a mixing stage in a multiple VCA module as well, and I have one of those in a kit coming probably in a couple of weeks. I don't know. It's coming from Wisconsin. It could take forever for all I know. I think that's pretty much it for this video. In the next video, I'll be talking about the noise and sample and hold modules so that we can get a little percussion going, hopefully. You got to have noise to do percussion generally. And by noise, I mean like white noise. So basically fairly fast random voltage. And so with all that said, thank you for watching. I'll catch you at the next video. Cheers. Okay, so hopefully that gives you an idea about what a VCA is, what it can do, why you would want to use one. I don't like the way I'm talking there. All right.